Showtime?
Yes, sir.
All right. Hello, I'm Ryan Mack, and I've analyzed data for 4.5 years, and one of the students that will graduate from the 17th cohort of Divergence Academy's data science 60-hour part-time course. So for my course Capstone project, I will use IBM's HR analytics employee attrition and performance data set to predict attrition here. So this is the outline of my talk. So I will start with posing the business questions, as well as providing a snapshot of the data dictionary and my findings from inspecting the data. Then next I will just go into exploring, engineering, and selecting the features for my machine learning models. Then I will then discuss the results of my supervised learning models, as well as the unsupervised k-means clustering. So this particular project, it will be tailored in IBM's setting towards their senior upper management and their HR department heads. And so IBM is interested in identifying which employee is likely to leave the company and what they can do to retain that employee. So employee turnover is a very important thing for IBM and even other companies, because high turnover will lead to loss of know-how, loss of productivity, and also increased costs when it comes to finding new employees, searching, also onboarding them and training them. So the two business questions that that they would pose for this particular project here, and that this project will answer, is which employee is likely to leave the company, and what can IBM do to keep these employees. Is it's this fictitious open source data set from Kaggle, and you can see the whole mouthful of a name for the data set. And the data set, each row represents an employee, and there are in the raw data set there are 35 features, one of which is attrition. That is the target variable or feature that we want to that I want to predict in this project. And then here is the snapshot of the data dictionary I put together, and you can see that there are three types of features. First, there's the famous target feature, the one that I want to predict. That would be attrition. So it's a binary variable, has two categories, no and yes. And then there are also 8 categorical features. There will be these binary features such as overtime, again has 2 engineering the categorical features. So there's the binary 2 category variables here, and for those categories, they're mapped either to 0 or 1 to produce dummy variables. That way you take those categories and you make it numeric here. For the nominal variables, I got the dummies for each of the nominal categories for all the categories, and I dropped one of the categories here because just one. Employee number is the ID, and standard
Sure.
hours is 40.
And hours were standard, 40 hours across the board.
Yeah, they're all standard 40 hours across.
So so the one way of doing that would be like, hey, is there a lot of variance in between hours of people, right? So if there was a lot of variance across the board, then that would carry a little bit of information. But in this case,
It was just uniform
okay,
distribution.
wonderful.
Yes.
Okay, great.
Thank you. Yeah, so this is, so I explored the 26 numerical features here by creating a correlation matrix. I understand that this is actually quite small, but so I would jump to my Jupyter notebook, and the range of the correlations go from 0 to 1, so there's not much of a negative correlation, and you could see here that there's some patches of positive correlation between two numeric variables, such as monthly be using it as the criteria for my variable selection, which is the next step here.
Sure.
So if we go back to the PowerPoint, and this is taking the time. That's what I did. I selected the features for my attrition model. So after doing all this feature engineering on the raw data set, I ended up getting 43 predictor features, and then I subjected them to all these 5 feature selection methods here, and they give you those methods give you the list of the selected features. So they give you a list of suggested features for modeling. So I took the features that had the highest frequency of suggestion, and then used the correlation. Something similar to backward forward selection.
Yeah.
That kind of thing.
So this one is also embedded feature selection, right? So because it's built into the algorithm.
Right.
So you got 2 of them, one random forest and extra trees. Both of them behave same way. Well, and this one is also after fit, right?
Right.
Okay, all right. And looks like the Iowa housing NumPy horizontal stack piece of code works, right?
Mm-hmm. Right.
You do a set on unique features and run them through, right? If I recall,
yeah,
that's Iowa housing piece of code.
The
Right.
Iowa housing.
I'm glad you're repurposing. Wonderful.
Okay,
Good
thank
job.
you.
Nice.
And that's what I used and examined closely to
Sure.
Do the feature
Okay.
selection. So, just takes a while to switch back to that world. In the end, I ended up selecting 11 predictor features for my attrition model here. So that provided me the final attrition modeling data where if you're wondering where churn came from, churn is the same as attrition, but churn is just the dummy 0-1 variable version of attrition, and the rest are all these predictor features, the 11 of them I picked for the model, the classification models, and then you can see here that monthly income and the overtime dummy variable are actually very interesting variables to note for the feature selection for the modeling, because if you see here,
there is nothing here that says it's because of you, manager, that people are leaving.
Yeah, it didn't say, how do you rank your relationship with the manager?
And that might be a data that is missing,
Yeah,
right? Because often that is, every single time I've left, at least that has been a very, very big factor.
right.
So, why is that not measured would be a question, right? Not
Don't-
just say, hey, this is the reasons, but hey, traditionally it's pretty well known that the manager does have an impact on the churn.
Mhm.
So why are we not trying to even quantify that would be a challenge that you would wanna ask
Right,
when you're given this data, right?
right, yes.
Or the other one, piggybacking on Wish, is can you engineer it with existing data? Can you create another feature,
Mhm.
derived feature, that kind of says something about manager?
Yeah,
I think data is there. There's somewhere we just have to come up with a formula for engagement with a manager,
so that could be another.
a derived
way
feature.
of,
You heard of R squared, right?
yeah, R square
How
value.
much of the change in all of this is explained by all these features, right?
Right.
So essentially you'll have residues, right?
Mhm.
Even using this model.
The confusion matrix, and then the accuracy I computed for here for the upon the test data, that's it's pretty high, but as you get to how confident I am in capturing the employees that left, it